Michael Harrison, and I'm a retired anaesthetist. This series of videos is about the enhancing of physiological monitoring during anaesthesia. Eddi is a basic form of AI, early detection of diagnostic information. It is deterministic. It does not rely on a large data set for its function. It cannot learn new processes, and it does not need an internet connection. It is therefore immune from hacking. Malignant hyperpyrexia is a rare but dangerous condition, and it occurs in certain families when exposed to some anesthetic agents. The other rarity is an oversight at the end of cardiopulmonary bypass for heart surgery. Be assured, it is rare. Malignant hyperpyrexia is notably associated with a rise in body temperature. It is caused by an abnormality in muscles. The heart rate and blood pressure goes up. Because more carbon dioxide is produced, the amount of CO2 in the exhaled breath is therefore increased. Unless detected early, it can be lethal. Detected early, drugs can be given to overcome the abnormal action of the muscles and other measures taken to control the temperature and other side effects. This condition was first investigated for computer diagnosis over 25 years ago. Fuzzy logic was used to define the course of this adverse event and enabled its detection almost 10 minutes before the clinician. Fuzzy logic is complex, so it is best to look this up as a separate exercise. The space between normal values and high values changes over time, and this increasing gap can be considered like a course traveled by a boat. If the value follows this course, then it can be considered as trending towards the diagnosis of MH. Here is a review of changes occurring during the onset of MH. Fuzzy logic accommodates the varying magnitude of changes and the time that these changes take. The algorithm is based on the analysis of several cases of MH. Because of its rarity, the condition has not been tested in practice. There is, however, one situation where the anaesthetists have to assess the alert: laparoscopic surgery. At the beginning of surgery, the blood pressure and heart rate may rise transiently, and with the insufflation of carbon dioxide into the abdominal cavity, exhaled carbon dioxide may increase. All the hallmarks of MH. They would be transient. It is to be noted that even during laparoscopic surgery, it is not impossible that MH could occur. The diagnostic changes, however, would carry on. Failure to ventilate after cardiopulmonary bypass. This, again, is a rarity. The heart-lung bypass machine takes over the need for lung ventilation during surgery, and the lung ventilator is turned off. When the heart-lung machine is turned off, the ventilator needs to be turned back on. Sometimes other urgent events are taking place, and it is possible for this to be overlooked. Eddi would detect this. To err is human. Early warning of an oversight is good. Eddi detects the time when the bypass is turned off, the respiratory rate, and the end-tidal carbon dioxide. Again, it has not been tested in practice, but simulation produced an alert with a sensitivity of 1 and a specificity of 0.94. Eddi is software that detects diagnostic information quickly and earlier than anaesthetists. It is a constant wingman for the anaesthetist, constantly vigilant and advisor. The anaesthetist is still in charge, is still responsible for the care of the patient. I hope you have enjoyed these videos. Please discuss the concept with your colleagues. It is not a black box. All its actions are explainable. It does not need an internet connection and is therefore safe from hacking. This is, in essence, no different from warning systems in aircraft. Anaesthesia is safe. Eddi, however, could make it safer, and it is hoped it would enhance the performance of anaesthetists.